In today's video, we're going to be talking about conjugates with imaginary numbers, or complex conjugates. Oops, there should only be one N there. And basically, it's very similar to the last video. A complex conjugate is basically when you have a binomial, like we do here, and you will be multiplying it by the same binomial. The only difference that comes into play is one will be negative and one will be positive. And the reason behind a complex conjugate is, again, going back to that square root, trying to cancel it out. If I think of it as square root of -1, I don't want that to be in the denominator. And when I go to FOIL this, I'll get x squared minus ix plus ix minus I squared. Well, the middle terms will cancel out, and I squared becomes -1. So minus the -1, x plus 1. So in these first two examples, what we're going to do is we're just going to divide, getting rid of the I in the denominator. So in this first one, because it's a binomial, we're going to want to multiply by complex conjugate, which will be 2 plus 3i. And in the numerator, you're going to have to FOIL. So you're going to get 6 plus 9i plus 2i plus 3i squared. While on the bottom, you can also FOIL, but remember those middle numbers are going to cancel out. So I'm just going to go ahead and skip ahead. 4 minus 9i squared. I'm going to simplify the numerator to get 6 plus 11 I plus 3 times -1 over 4 minus 9 times -1. I'm going to keep simplifying that. 6 plus -3 is 3 plus 11i, and then this will be plus 9, so over 13. Now in example number 2, you'll notice it's not a binomial, but there still is a square root, that imaginary number in the denominator. So I'm going to multiply by the radical. So I don't need to multiply by 5, so I'm just going to multiply by I. So this will give me 6i in the numerator, and then 5i squared in the denominator, which, if you remember from last video, is -1. So you have 6i over -5. And finally, the last concept, we're going to talk about the power of I. In the last video, we talked about how I is really the square root of -1, and that I squared is square root of -1 times square root of -1, which is -1. But what happens if we keep going with this? I cubed, I to the 4th. Well, I would have 1, 2, 3. And we know that 2 of these equal -1, so it's really -1 times square root of -1, which I can change back to -I. So I cubed simplifies to -I. Well, what about I to the 4th? Again, every 2 becomes -1. So if I have -1 times -1, that actually becomes +1. So kind of the exponents that are even are kind of important, because they turn into those real numbers, -1, +1. Well, what happens with I to the 5th? I would have 1, 2, 3, 4, 5. And we now know that every 4 is +1. So this is +1. And then this is square root -1. So it would be 1 times I, or just I. So in reality, when you get to 5, or I to the 5th, you kind of go back up and it becomes I to the 1st. When I do I to the 6th, the same thing applies. I'm going to have 6 of these, And I know every 4, oops, I'm short 1, every 4 becomes positive 1, every 2 becomes negative 1, so that becomes negative 1, which is really the same as I squared. So after every 4, it kind of cycles back into that rotation. So what you have to do is you kind of have to think about if it's a higher power, how is that going to apply? Well, I to the 11th, if you think about how many times that rotation is, it's 4 times. I squared, I cubed, I to the 4th. Then once you get to I to the 5th, it starts repeating. So it's every 4 it starts repeating. So 4 can go into 11 3 times. And there are 3 remaining. Okay? So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, you definitely wouldn't want to write this out all the time. I'm just showing you kind of what's happening. So I think to myself, okay, 4 can go into 11 3 times. There's 1, there's 2, I'm sorry, 4 goes into 11 twice. Sorry. Thinking goes into 12. Okay, so 4 goes into 11 twice, and there are 3 left over. So the remainder is 3. So then you just got to think about what is I to the 3rd. So then you kind of go back to that chart and you say, okay, I to the 3rd equals negative I. So I to the 11th is the same as negative I, or it reduces down to negative I. You can do the same thing with any exponent. So how many times can 4 go into 50? Well, it goes in 12 times, because that would be 48, 4 times 12. And then, so there would be a remainder of 2. So then I would have I squared. And we should hopefully know I squared is negative 1. So I to the 50 is really negative 1. All right, go ahead and try number 5 and number 6. So 4 goes into 40 evenly, goes in 10 times. So all those 4 would be paired off, so that is just positive 1. All right, hopefully some of you maybe caught on to number 6, I to negative 10th. Well, negative exponents, you need to move them down to the denominator. So it's 1 over I to the 10th. Again, you're going to do the same thing. How many times can 4 go into 10? That's twice, with a remainder of 2. So now I'm really looking at what's the remainder of 2, which has to be, or which is negative 1. So that's going to simplify to negative 1.